Alright, I started doing this and kind of got a ways in and then forgot to autofocus. So I'm going to double check it now. And then they're written out, so I'll just explain. So pretty much, 1, you're switching the x for the y and carefully solving. Number 2, you're pretty much doing the same thing, switching the x for the y and carefully solving. In this case, this was just basic algebra, but in this case, you had to, once you got to the x over 3 is log base 6 of y, please don't forget you lift both of them up into exponent position by using base 6's, and then the 6 log 6 disappears to make it y is equal to the 6 of x over 3. If you look at number 3, it says please explain the difference in asymptotes. So you use domain to find asymptotes, because then that would be where it is not a function, or where the function is undefined. So in this case, x can't be 0, so vertical asymptote is at 0. X can't be 4, so vertical asymptote is at 4. Same thing here, negative 4, and then back to 1 over x, or x has to be 0. So the differences are these two have vertical asymptotes at 4 and negative 4. These two have the zeros. Horizontally, the asymptotes are all the same, because n, or the degree, is less than, the top degree is less than the bottom degree, so the horizontal asymptotes are all y is equal to 0. Okay, so if you take a look at number 4, again, vertical asymptote is at 6, and then horizontal asymptotes, because they have the same degree, it's the leading coefficient, so 1 over 1, so y is equal to 1. So we graph our vertical asymptote, we graph our horizontal asymptote, and then you would use your calculator to just find some points to fine-tune the arc here and the arc there. Okay, number 5, again asymptotes, so we factor the x squared plus 7x plus 6. So our domain is x can't be negative 1 or negative 6, so those are the vertical asymptotes. And again, my horizontal asymptote would be at y is equal to 0, because the degree on the top is smaller than the degree on the bottom. The 4 under 6 can all be treated in, or written into two binomials by doing completing the square. So pretty much once we do that, those are all going to have at least 2 real zeros, because you can solve all of that. So B would be the only one that will not work in that case. Okay, number 7, we're doing the domain. So again, do your denominator. X can't be 0, x squared minus 9 can't be 0. So our vertical asymptotes are going to be at 0 and plus or minus 3. So interval notation, we do from negative infinity to negative 3 in union with negative 3 to 0. So each of these would be the x-intercepts. And behavior is nothing more than using this chart. So you just decide, is it positive or negative, and even and odd. So in this case, it goes up on the left, down on the right. So as x goes to negative infinity, the function is going positive. As x is going to the right, the function is going to negative infinity. Number 9 is that difference quotient thing I talked about. You're just plugging in the m plus 2 into the x. In this case, you really can't factor anything, so I would accept pretty much either one of those as an answer. Okay, number 10, we're graphing cosine. So we need an A and a B. Period is 2 pi over 1, so 2 pi. Interval is 2 pi over 4 or pi over 2. So our x's are shown. Our cosine pattern starts with 1, and we multiply by the A. So if we graph just this much, that would be 1 period. If you would go further, you'd have 2 periods. And in this case, it doesn't say what to do, so 1 would be enough. So just this piece would be enough. Okay, if we take a look at 11, again, we're defining the A, B, and the C. Our period is 2 pi over 1, so 2 pi. Our phase shift is pi over 2 over 1, so and the interval 2 pi over 4 or pi over 2. We have to find our n's by using the phase shift portion. So x minus pi over 2 has to equal 0 and 2 pi. There's our n's. Again, we find the middles by adding the intervals. We use the sign pattern, and then we multiply by 2. So that is our graph. And again, from this point to this point would be one period. If you continued it, you would then have a second period. So you would still have an x-intercept at minus pi over, and then at minus 3 pi over, and at minus 5 pi over. So the picture would continue. Okay, number 12 is law of sines. So we pretty much just set up filling in what we know, and then we cross multiply. We get the 31 because we know the inside of a triangle equals 180, and then just solve it out. Okay, number 13, equation of a sine function. Amplitude is 4, period is 8 pi. 2 pi over b is equal to the period, so if you solve that out, your b is 1/4. So the equation would be y is equal to 4 times the sine of 1/4 x, or x over 4. Number 14, amplitude is always an absolute value number, so it's a positive 7. Period is 2 pi over b. In this case, b is a 1. And phase shift is pi over 1, or pi. Okay, another inverse. So we do, the function is natural log of x plus 2 minus 4, so we switch the x's for the y's. We do normal algebra until we get to this point, then we lift it up because we have to get rid of the natural log. So these both become exponents, and then we have just y plus 2 is equal to e to the x plus 4, so we subtract the 2 and get our inverse. X to the 4th minus 81 is a polynomial function, and we're talking zeros. So for number 16, we have 4 zeros. The possibilities are 4 real solutions, 2 real solutions, and 2 complex, which are 2 imaginary, or 4 complex, which are 4 imaginaries. So if we solve out x to the 4th minus 81, we end up having a plus and minus 3 and a plus and minus 3i as our 4 answers. So you factor and then solve. So part C then says let the function be x to the 4th plus 81. So what happens is there we still have to have 4 answers, but they are imaginary answers because the graph never crosses the x-axis, so we have only 4 complex or 4 imaginary answers. And it really, it's a negative 3, but because it's a plus minus, you don't really need the negative 3 part of it. It just becomes plus minus 3i. Number 17, we're identifying the asymptotes again. So we solve the denominator for the vertical asymptotes. In this case, you'd probably make it into x is equal to a decimal number because you need to graph the asymptote. And then again, our exponents were the same, so the horizontal asymptote is the leading coefficients, or negative 1 over 1. So a horizontal asymptote is y is equal to negative 1. Conjugate, you just change the second part, so negative 3 minus 12i. And then 19, we're multiplying by the complex conjugate, which is this. So we multiply both sides by, both the numerator and the denominator by 5 minus I. So we FOIL it out. We end up with this piece here. We combine our i's. Don't forget the I squared becomes a negative 1, so it becomes a negative 6. So 19 minus 35i over 26. Okay, so we're on number 20, so we're going to graph our cosine. So this will be same review as before. So A is 3, B is, oh, that's supposed to have an X on it, sorry. So B is pi over 2, and period is 2 pi over 2, or 4. An interval is period divided by 4 or 1. So we do not have a phase shift, so we're going from 0 to period. It's a cosine, so pattern, and we're multiplying by the amplitude, so 3, 0, negative 3, 0, 3. So in this case, I'm going to change these to 1, 2, 3s, and 4s. So at 0, we're up. At 1, we're at 0. At 2, we're down. At 3, we're back at 0. And at 4, we're back up at 3. So it's a cosine graph. It should have that one valley picture. And if we continue to a second period, we could go this way or this way, but we would have the same x-intercepts, so negative 1, negative 3. So this would come down, the 2 would go to the negative 3, and then the 4 would go back up. So that would be a picture of two periods. Okay, the graph of a cosine has an amplitude 3, period, pi over 4 in a vertical translation. Write an equation and then sketch it without using technology. So y is equal to 3 cosine of 8x minus 2. And we got that from the amplitude is 3, so the a is a 3. 2 pi over b had to be equal to the period. So b, in this case, had to be an 8. And a vertical translation of 2 down is just the number by itself minus 2. So we do our zero to period. Our interval is going to be, let's see, so we said our period was pi over 4, so divided by 4. So our interval is going to be pi over 16. So pi over 16, pi over 8, 3 pi over 16. So I'm just going to regraph or recall these. So pi over 16, pi over 8, 3 pi over 16, and pi over 4. So at it's a cosine. So pattern is 1, 0, negative 1, 0, 1. We're multiplying by the amplitude. So 0, sorry, 3, 0, negative 3, 0, 3. Okay, we're skipping 22. So 23 says sketch the location of 3 pi over 2 radians on the unit circle. So 3 pi over 2 is right here. And then it says please find 2 other radian measures that refer to the same point. So 3 pi over 2 plus 2 pi is going to be 7 pi over 2. And 3 pi over 2 minus 2 pi is going to be negative pi over 2. So that would be 2 different names for that. The 6 trig functions, again, we're going over and down. So negative 8, negative 15, you use Pythagorean theorem, and you just find your x, y's, and r's are your opposites, adjacents, and hypotenuses. So sine is negative 15 over 7. Cosine and then we do our reciprocals. So and then don't forget, use the all students take calculus to check to be sure that the tans are positive with the reciprocals and that the sines and cosines are both negative in quadrant 3. Okay, we're going to use the law of cosines for triangle on 25. Because if you fill it out, so pretty much E over sine of E, F over sine of F, and G over sine of G, we have the 30. We do not have the sine of that. We have the 17. We do not have the sine of that. And we have the 22, but not the sine of that. So in the case of this, I'm going to go for the biggest angle. So I'm going to find angle E. So we're going to do cosine of the angle is going to be, so I'm going for let's see, what do we decide? So we're doing cosine of E. So we're going to start with E. So we're going to do 30 squared, and then, okay, I'm sorry, I just realized I didn't do it following your sheet. I'm just going to give you the answer, and then I'll come back and just put a piece of paper out with the solving on it, because remember I talked about there's pluses and minuses in different places, and I just realized I did mine with a different formula that's not on your sheet, and I don't want to throw anybody off. So I'm just going to give you answers on here to check, and then I'll put another piece of paper on the Google to show the work. So we have angle A should be 100 degrees, and then we use our sine, or our angle E, I guess, sorry. Angle E should be 100 degrees, and then we use our law of sines up here to fill in the rest of it. So angle, see, I labeled them differently, so then F should be 34 degrees, and G should be 46 degrees. So I'll come back to this one on paper. Like I said, I just realized my solving looks a tad different, and I don't want to confuse anybody, so I'll put it on as a kind of an addendum. Okay, so if we look at 26, we're solving using an angle with the sides. So pretty much we're going to just do a squared is equal to 7 squared plus 16 squared minus 2 times 7 times 16 times the cosine of 100 degrees. So we solve that out. Your A is going to be 18.544. Then you're going to go back and use your law of sines. So we have 18.544 over sine of 100. We have 7 over sine of B, and we have 16 over sine of C. So we can just solve this part out. If we solve that part out, we're going to say sine of B is equal to 7 times the sine of 100 divided by 18.544. So again, don't forget you're using your inverse button. So angle B is going to be 22, and then C is going to be 58. Okay, 27 is law of sines again. It's just you have to draw the picture. 27. Okay, so we have our picture, algebra calculus and arithmetic, the information we're given is this and that, this and an x. So pretty much just do law of sines. So x over sine of 52 is going to be 532 over sine of 35, because remember, once we have these two, we can always fill in the third angle. So we just cross multiply, and it should be 730.891. Okay, the last one involves a cosine fraction. So if you think about it, you have y is equal to 22 minus 4 cosine of pi over 6t. So if we solve this out with the a's, the b's, and the c's, our period ends up being 2 pi over 6, or 12. Okay, so what that means is we do not have a phase shift. So if we make our chart, we're going from 0 to 12, and our interval is period over 4. So it's going to be 3 apiece, so 3, 6, 9, 12. And it is a cosine. So 1, 0, negative 1, 0, 1. We multiply by the negative 4, so negative 4, 0, 4, 0, negative 4. But then we have to add the 22. So 18, 22, 26, 22, and 18. So if we graph this, okay, so we're at 0 is up at the 18, 3 is at the 22, 6 is up at the 26, 9 is back at the 22, and 12 is at that. So here's our graph. Okay, so it's a cosine graph. So now how you interpret the graph is, remember, t of 0 was supposed to be midnight. So that means this is midnight. Okay, this is 6 a.m. and this is noon. So what's happening for high tides, so this is my maximum, this is my minimum. So this is low tide and this is high tide. So to answer the question for when are there high and low tides and what are the depths of each, high tide is at 6 a.m. and it goes up to 26, and low tides are at midnight and noon, and they go down to 18. So, and then the last one you can ignore. Any questions, send me an email.